proving identities algebraically. I'm going to take a look at you in this video with two examples, and they're both going to be rational identities or rational expressions that are identities. But there are all types of identities. There are multiplication identities, there are factoring identities, and the goal with proving that something is true or proving that something is an identity is that you want to work with one side at a time. You never want to cross over that equals sign. You want to show that the left side is equal to the right side. So what am I talking about? Let's take a look at this example here. Algebraically prove that x cubed plus 9 over x cubed plus 8 is equal to 1 plus 1 over x cubed plus 8, where x does not equal 2. So we don't need to worry about that x does not equal 2. We want to worry about this piece here. And I want to prove that the left side equals the right side. So x cubed plus 9 over x cubed plus 8 is equal to 1 plus 1 over x cubed plus 8. I'm only working with one side. I can't do both. I can't add and subtract, subtract from the left, move it to the right, and things like that. So I want to work with the side where it looks like there's something to be done. So on the right side, if you notice, there's an addition sign. There's something to do. So I'm going to add. So if you need a refresher, there is a video on adding and subtracting rational expressions. But what you're going to do is you're going to multiply by what's missing. Now remember that 1 or any number can be put over 1 to make it into a fraction. So that's the first thing I'm going to do. I don't have like denominators. I have 1 and I have x cubed plus 8. In order to add, you need like denominators. So I'm going to multiply by what's missing. So x cubed plus 8 is missing. And then in the next one, I'm missing a 1, but you don't have to multiply by that if you don't want to. So if you notice, anything times 1 is itself. So I have x cubed plus 8 over x cubed plus 8 plus 1 over x cubed plus 8. So now that I have common denominator, I'm going to combine my numerators. So I have x cubed plus 8 plus 1 over x cubed plus 8. In my numerator, I have like terms. I have an 8 and a 1. So when I combine them, I'm going to get x cubed plus 9 over x cubed plus 8. Now, if I go all the way back up, that's what I have over here on the left side. So x cubed plus 9 over x cubed plus 8 is equal to itself. So that's how I know I'm finished. Once my left side is equal to my right side, I'm done. Let's take a look at one more example. Algebraically prove that 2x squared minus 9 over x squared minus 4 is equal to 2 minus 1 over x squared minus 4, where x does not equal positive or negative 2. So I'm going to start by writing this as a 2 over 1, and then I'm going to multiply by what's missing. This is missing an x squared minus 4. And remember, when you are multiplying by what's missing, you have to multiply in the numerator and the denominator to keep that balance. So this is really going to be distributed, this 2. So I'm going to end up with 2x squared minus 8 over x squared minus 4. If you need to show that on the side this way, just because that's what you're used to, that's fine. And then I have a minus 1 over x squared minus 4. So if I continue, I'm going to get 2x squared minus 8 minus 1 over x squared minus 4. So in my numerator, I have a minus 8 and I have a minus 1. My like terms can be combined. So I have 2x squared minus 9 over x squared minus 4, which if I go back, that was my left side. This piece is the same. 2x squared minus 9 over x squared minus 4. I'm done because my left side equals my right side. So like I said, there are all different types of proving algebraically. You can have something that looks like this, for example. A plus b squared is equal to a squared plus 2ab plus b squared. Prove algebraically. So you would have to work with one side and not the other. That's your goal. Work on one side alone, get the left side to equal the right side, regardless of the type of problem, the operation, whether it's multiplication, addition, subtraction, division, it doesn't matter. Algebraically prove means work with one side, leave the other side alone, and get them to match.